Many thanks for joining us today. My name is Gianpaolo, and I'm here with Troy to take you through what is new in ELN and Data Discovery for release 7.3. Troy and I are product owners of ELN and Data Discovery. Our presentation should last 40-45 minutes, and we'll have some time at the end for Q&A. If you have any question, please do type them to the Q&A module, and we will aim to address them after the presentation. We are planning to cover 6 topics today. I will kick off with the chemistry enhancements, spanning Elemental, the chemistry toolkit, and our cheminformatics application. I will then switch topic and cover the ontology search capabilities in data discovery, followed by our efforts to improve the integration between data discovery and Prism. At this point, I will pass the ball to Troy, who will cover integration between Prism and ELN, new capabilities for statistical analysis in screening, integration between ELN and Luma Lab Connect, and finally, enhancements to process capture and multi-experiments workflow. Okay, let's begin with chemistry. We made important improvements to Elemental, both in terms of UI, UX, and new functionality, to the chemistry toolkit, where we've done work to consolidate the depiction of chemical structures and chemical reactions across different platforms, and our cheminformatics application reaction workflows and reaction explorer. The layout of Elemental has been completely redesigned in 7.1, and the new layout is now available across all our applications, including Bioregister. The main changes in the layout are that all the drawing buttons have been positioned on the left bar, whereas the top bar contains transformation like moving, centering, optimizing the layout. Other transformations have been added to the top bar, making them more accessible, including structure rotation and structure flipping horizontally or vertically. Structure rotation has been significantly improved. Now it works really smoothly and follows very accurately the movement of the mouse. Elemental comes in different sizes, giving you plenty of flexibility. This is the tall version. Then we have a slightly shorter version, exemplified here by Elemental embedded in Workspace, where the halogens buttons have been collapsed into a single menu. If you click the icon indicated by the red arrow, the size of Elemental will be maximized and a pop-up will open. The pop-up can also come with dedicated buttons, like in this case for data discovery, and we can use these buttons to run a search directly from within Elemental. Elemental can now cope with mol files which do not contain coordinates. It can happen sometimes that the customer ships a mol file which does not contain atomic coordinates. Previously, Elemental would generate an error. Now it can successfully load these mol files as Elemental can generate a layout. We have improved the rendering of dative bonds. We see an example here with ferrocene, and also the rendering of sequences. We have some examples of sequences loaded from a mol file, and now they are currently rendered in Elemental. And to the right, we see a comparison of how the same sequences are rendered in ChemDraw. Moving on to enhancements to the we have efforts in improving the consistency of the drawing of chemical structures across our applications. Chemical structures are moved frequently from one application to the other. For example, when we run a query in data discovery, the results of the query can be used to create a workspace, or the products generated in reaction workflows can be used to create an experiment in ELN, and these experiments can then be analyzed using a Reaction Explorer. When we move structures, chemical structures from one application to the other, we very often convert structures between mole and SMILES formats. And when we do so, we need to ensure that all information is preserved. This enables us to to preserve the chemical structure orientation and also to comply with drawing conventions. In version 7.3, when converting from mole to SMILES format, the extended notation can be used to support superatom S groups, wedge and weakly bonds information. In this example, this molecule loaded into elemental from a mole file contains an S group, the methoxy group, which is here represented by a label. The chemical structure underneath is still present, and this S group can be either expanded or collapsed, like in this case. In the previous release, when we convert this mole file into SMILES, and then we use the SMILES as input for the depiction, this would be the result. We lose the information about the S group. The S group is expanded, and in this case, the terminal carbon atom goes and overlap with another carbon, giving the illusion of forming an additional ring, which creates confusion, to say the least. In 7.3, when we convert from mole file to SMILES, the information about the S groups is preserved and embedded in the extended notation. When we depict, this is the way we depict now in 7.3, and the depiction is now consistent with what we see in elemental. In this other example, we see a carboxylic acid, which is connected to the heterocycle through a wedge bond. Again, in the previous release, converting to SMILES and then depicting, we will lose the information about the wedge bond, and we would add a split hydrogen to the structure. In 7.3, the information about the wedge bond is captured in the SMILES, and with the depict, we have consistency with elemental. Likewise, we preserve information about weakly bonds. In this case, the weakly bond is used to denote that the configuration of this double bond is unknown. And in version 6, this bond would have been depicted as a flat bond, but now this information is kept and we depict it in an appropriate way. Importantly, if we convert these SMILES strings back to mole file, the information will be preserved. Moving on to reaction workflows. In reaction workflows, when we have reactants with multiple reactive centers, we can have multiple reactions. This is because a reactant containing multiple reactive centers, like in this case, this reactant contains 2 amino groups, will react twice and will generate a couple of products. A common request from users was to combine this into a single reaction, which is closer to reality, as this product would be formed in the same experiment. Let me play a video to show the behavior. So the standard behavior is that when we use this reactant with this N-alkylation, 2 products will be formed because we are reacting the reagent in a sequential way. So we form 2 reactions, each containing 1 product each. We have now exposed the possibility to concatenate these products, to combine them in 1 reaction only. And we can access this option going to the preferences, and we have now a radio button to combine all the products in a single reaction. So depending on the setting that we choose, we can either work in a sequential fashion or we can combine the products in 1 reaction only. Reaction workflow comes with a collection of nearly 300 chemical reactions. However, there are times when the user needs to draw his own reaction. However, this is difficult to achieve. It's not easy, for example, to understand if the reaction has introduced an error and if products have been generated with a bad valence. In this example, this reaction is not specific enough. The methylation, which is expected to occur on this pyrrosol nitrogen, is also occurring on this bridge nitrogen. And this is an invalid structure. Now, this situation can be adjusted by introducing an explicit hydrogen as a modification to this reaction. Another error that is frequently observed when importing reactants from SDF is that structures are missing hydrogens on aromatic nitrogen. Here it is an example with an indazole structure. And this is really due to a malformed mol file which contains aromatic bonds instead of alternate single double bonds. The problem is that the structures are invalid, and when we send the structures to the ELN, any subsequent calculation will be wrong, for example, calculation of molecular weight. So it is important to warn the user that he may be dealing with invalid structures and offer options on how to fix them. In this example, this workflow generates invalid products, and we see that we have a red icon display on the front of the node to warn the user that invalid structures may be present. And indeed, one of the products highlighted here in red has a bad aromaticity. At this point, the user can do two things. One is to remove the offending reactant from the list of the reactants. The second one is to introduce a normalized node and use the option to sanitize aromatic hydrogens on nitrogens. This is a brand new functionality that we have introduced in the chemistry toolkit, and we have exposed through RW. Finally, Reaction Explorer. Reaction Explorer is a great tool for mining chemical reaction data. We use Rx as a synthesis exploration tool. An important additional use case for Rx is to ease the pain for the customer in generating patterns. In doing so, a scientist will select a number of experiments in Rx, and he will export them together with the structures of chemical reaction to a Word document. In the previous release, however, the orientation of the chemical structures is not preserved, and neither is the salt form. And because of this, scientists need to spend significant time in amending the reactions in the Word document, and this effort is also prone to errors. In 7.3, this issue has been fully resolved, and the structures exported by Rx to Word are now consistent with what is stored in the ELN experiment, with greatly improved usability. Okay, let's now change topic and talk about ontology. In data discovery, we have implemented an ontology search capability with synonym expansion. In the ELN, we have enabled a strict mode when using a type ahead associated to an ontology. On a data discovery form, we can associate a query field to an ontology. When we start typing in the field, a list of options is displayed. We can select one and run the search. If we double click on the field, a pop-up will be displayed. And in this pop-up, we can perform a synonym expansion. We can run an API to retrieve the full list of synonyms for the current term. Can then be inspected visually and edited. And the final list of synonyms can be applied and sent back to the form. and can be used with any operator for searching. This pop-up has been fully redesigned. The most important change is that the text area and the list of options underneath are now fully in sync. So any changes to the text area will be reflected in changes in the list below and vice versa. This has enabled us to rationalize the buttons. Now we have a single apply button. We have also introduced a clear button, and the get synonym button will be displayed only if the field is associated to an ontology. Let me play now a short video to show you the behavior. From the home page, we create a new query. We then use the type ahead menu to select an option. We run the search and we retrieve one hit. We now go back to the query, we double click and open the lookup. As I said, now the text area and the field and the option underneath are in sync, so any change will be propagated. And we can use the synonym button to retrieve the full list of synonyms, which can then be inspected and amended. We now click the apply button, send back the list to the form, and with the N operator, we run the search, which is now retrieving 2 results. Let's now go back one more time to the query, double click. If we try to retrieve synonyms and no synonyms are found, a toast message is being displayed. We can also select multiple terms and search for synonyms for multiple terms. Like in this case, we select 2 terms, run the synonym search, and then apply the full list back to the form, run the query, and in this case, 3 hits are returned. Let's move on to the ontology in ELN. By default, a type ahead associated to an ontology can accept free text. So given an editable table in ELN and an ontology-related column, the user can enter a value that is not present in the ontology, and that value, that text, will be accepted. We now have a global settings to enforce a strict mode. If this checkbox is checked, and if the user tries to enter a value or some text that is not present in the ontology dictionary, then this term will be rejected with an error. Integration with Prism. In 7.3, we made important changes to the way we integrate with Prism. The most notable change is that we no longer support Prism 9 and its templates. We now support only Prism 10. Another important change is what we export from data discovery. Previously, when we export data from data discovery to Prism, we only exported replicates as mean, standard deviation, and count, meaning that scientifically important information is lost in the Prism export. In 7.3, we export individual replicates, which gives you the opportunity to run further statistical tests once the data are in Prism. So this is an example we use to export all the replicates exported as mean, standard deviation, and count. And these are examples of what we export now for Prism 10. We export all the individual replicates for each sample, for each concentration. This is an example where for each sample and each concentration, we have the same number of replicates, and in this case, we have a variable number of replicates. In the bottom scenario, empty columns may be present because because the number of replicates for each sample, for each concentration, must be set to the maximum number present in the spreadsheet, which is 3. When we export screening data from data discovery, Prism, we can retain the status of knockout points. In this ELN experiment, for example, the user has excluded a number of data points from the analysis as they may consider outliers. This information is now included in the Prism export from data discovery. And the knockout points are marked once loaded in Prism in blue color and italic font. These data points will not be included in any calculations or visualization generated in Prism. However, they can be easily reintegrated. Let's play a video to see the export in action. So go into the screening project. We select an experiment and we run a query. And then we click on the dedicated button, which is available out of the box. And these are the individual replicates exported to Prism. Let's now go back and let's go to ELN, to the ELN. Let's open experiment. And let's try to knock out a few points so that will not be included in our statistical analysis. We can see in red that those 3 points have been knocked out. Let's go back to data discovery and create a new query. Let's search again for the experiment. Now the data exported to Prism will retain the information about the knockout points. As you can see here, display in blue. We can use now this data to try to generate a visualization like we had in the ELN. And we can see now that the knockout points are not being displayed in the visualization. They can be easily reintegrated simply with a right click. And now the points will appear again on the visualization. Okay, we have reached now half point, and I'm going to pass the ball to Troy, who will give you further information on the integration between ELN and Prism.
Thank you, Java. Let's see if you can stop sharing. That'll allow me to share. All right, thank you. So I'll next review the new Prism export capabilities from a screening experiment. Exporting to Prism remains available from the Layers tab within a screening experiment, and produces a .prism 10 file type. The workflow is generally unchanged. However, users are no longer prompted to select a template. Within Prism, after opening the exported file, you'll see sample replicates again grouped in an XY table. So we see under sample 1, 3 replicates here, for example. Additionally, each distinct well type is exported into a dedicated XY table to simplify the next steps of analysis and curve fitting, which you really only do on those values that are samples. And so we do this by better organizing the controls and controls where there may be dramatically different numbers of replicants from the sample that you see in this experiment, where there are 48 high and low control, 48 high and low controls. So I will next show you a quick recording of this workflow. And click start here. Find my play button. All right. So I'm in my screening experiment. I select export to Prism, and now I'm going to open my Prism 10 file. And here you'll see that XY table for samples with the replicates grouped. Here I've got 4 replicates across my 8 different samples and separate tables. Now you can see that the controls don't often have dilution series with them, unlike samples. Another good reason for putting them into separate tables. All right, so continuing with a focus on screening experiments, we've added a new weighting option when you configure your screening analysis. We now have 1 over y squared. 1 over y squared weighting is typically used when you expect the average distance of points from the curve, from the fit curve to be higher when y is higher. So your concentration gets higher, the values get bigger. We also still have available Tukey's by weight and Andrew's sign. They remain options for admin when you're configuring these analysis, and we've just added this new option. We've also added to screening the ability to calculate a one-way ANOVA p-value. So for each replicated sample on the analysis tab and in screening, you'll see a reported p-value that you can use along with other curve fit parameters to validate and make decisions about your samples. This is all configured as a derived analysis in the system. When you're configuring an analysis, you simply put into the formula ANOVA p-value. That becomes available then in your protocols as an admin. You can add those analysis with that calculation. Here you can then now see what it looks like reported on the analysis tab. Again, you'll see a large p-value would mean there's no change in activity across that dilution series. So hopefully you can start to identify insignificant results. And that provides really another tool to make decisions about your results. Let's see. In the past, continuing on with new enhancements to screening, the interfaces, the screening interfaces were always the first forms in an experiment right after the info tab, and you couldn't change that. So now admin can manage those 3 screening forms like you can any other form in the system, the screening tab, the options tab, and the charts tab. And you do that in the section of protocols where you manage the forms. And what this really enables is a left to right workflow through your experiment as you navigate through the tabs. You're not forced to have all of the screening interfaces first in the protocol. And so I'll show you that in this video here. We'll play. I'm in a screening experiment. And you can see that I've made additional files and options come before the screening and charts tab. I'll just play that again for good measure here. Oops, play. There we go. Sorry, wrong video. There we go. So I've added my plate reader manual as my first tab. Now my options, analysis tab before the charts tab. All right, switching gears away from screening, I'm going to transition now to talk about Luma Lab Connect integration with the ELN. LLC, or Luma Lab Connect, is a Luma application enabling automated ingestion of your scientific instrument data files. LLC can then serve as a central file repository that can track file versions and is aligned with fair data principles that Luma supports. And so we now offer a seamless integration of LLC and LLC files with ELN experiments. And I'll show you that in this video next. I'm going to start in my ELN experiment in the documents section. I'm going to launch Luma, and I'm going to select files I want to associate with my experiment via a hyperlink. And if I click play here in my video, now I'm going to launch Luma. Now I'm navigating the file structure to find the file from this file repository. I'm going to pick one of an image of some cells. Now I have the option to send that to the ELN. I can give a reason that's going to be captured in the ELN that I've attached this file, this permalink to a file. And that's going to bring me back to experiment where I can now see this hyperlink to that file. If I click on it, it'll again launch Luma, and I can preview that file. I can download it from here and work with it in the file repository. Alternatively, I can also add that file directly to the ELN database associated with my experiment. So I'm going to repeat this. And this time, instead of link with the hyperlink, I am going to select attach. And now if I go to the Files Documents tab, it's treated just like if I'd uploaded the file directly into the ELN, and it's in the database. So similar functionalities are available for group sets of files, shared groups of files. So an example there might be the output of a plate reader where each plate is a different file, or a sequencing run where there's different sequences in individual files that can be grouped and added. And a similar integration is available in screening that for associating raw data files through that screening experiment, and then begin the process of parsing the data from them within the screening experiment. All right. That's the Luma Lab Connect ELN integration. I'm next going to discuss new features in our formulation in ELN after a quick introduction. For those of you that are new to the Dotmatics formulation ELN, the formulation ELN enables capturing and linking ingredients information, recipe steps, and analysis results associated with a formulated product. So there are three types of formulation ELN experiments. There's a process experiment, and that is where users define and execute the recipes to make a formulated product. What ingredients did I use, and how did I make that product? Test experiments are where a user would analyze and characterize either intermediate samples or final samples of those formulated products, really asking how did my formulated products perform. And those all could be collated in what we call multi-experiment workflow experiments. They're really can be components in that larger pipeline, that larger network of related experiments. And that can serve as the hub that enables really tracking that lineage and genealogy of ingredients across multiple experiments for scenarios where you might have an experiment that generates a precursor product that becomes an ingredient in a downstream product. The use case for multi-experiment workflows is that enables that tracking. So with that introduction, I'll say that the formulation ELN is the most rapidly growing area of our ELN. That's going to continue into the future. And I specifically mentioned release versions in this slide because which version of your company is running will have a big impact on the available ELN features, both now and into the future. So be aware of that if you're looking for a new feature. So let's review some of these new features next that were listed there. All right, in this demo, I'll show you new process design templates and expanded ingredient role capabilities to track what a component ingredient is doing in that formulation. So I'm going to play my video here. I'm starting in a process experiment. I'm first going to create that experiment. And that'll load an experiment with an empty process design. I haven't defined my recipe yet, but I now have this option to apply a saved template and populate my process from that saved template. And doing so, it's created all the steps, actions, ingredients, and variations. You can see 3 variations there in my process recipe. And I'm just scrolling through. All of the values have also been populated from my template. Here you see now the new roles column where I can now select from my available roles, from an admin-controlled dictionary of roles. I'm simply going to edit a particular role across my 3 variations here. And I can see those roles set in each of the next steps in my experiments. On the review tab, I can see the roles as a review. Once I select to formulate those and send them to the formulated products table, I can see those roles set here. And then in the final interface, where I'm capturing what actually happened in those experiments, I can also see the roles in the table on the right, hopefully allow me to make some informed decisions about the products I've made and the values that I actually used in those experiments. So templates and roles demonstrated in that video. All right. I am next going to talk about ways we've made it easier to enter ingredients and ingredient amounts, and do so in a way that most of our chemicals and material R&D users think about formulations. It's what we're calling simple modes of entry. And let me start here. I'm going to, again, create my process experiment, and I'm going to apply a template again this time. However, I've not specified the ingredient amounts. They're empty here. There's a new field available for target amounts. I can change that target. And now I'm going to simply change the mode of entry here to enter as percentages. And I can enter percentages of that total, and the system will calculate the actual amounts as I go. And yeah, now you can see if I enter that step specific total, that'll also trigger an update of those calculated amounts. Everything increased by a factor of 10, and I can move that back. I can also enter these data as a ratio, a relative ratio. And again, the system will calculate the actual amounts based on that targeted total of 500 grams in the unit I've selected in the above field as well. And so now I'm entering my ingredients as relative ratios. And if I can simply now go add a second variation if I want and update the ratio for that particular variation. I could do the same with percentages. And continuing on then, as you might expect, in the review tab, I can see the calculated amount as well as those ratios for each designed variation. And when I select to formulate, it pushes those actual amounts into the tabular grid view of my formulated products. All right. In this final demo, I'm going to show you multi-experiment workflows. Again, multiple experiment workflows is where I can define experiment relationships and build these tiers of networked or linked experiments. And I'm going to start, as I play this video, with an empty multi-experiment workflow by creating that workflow experiment. Going to my workflow tab. And now we've extended the ability. You can see a new button here for add existing experiments. So we've extended the ability to create workflows that include pre-existing experiments in addition to creating new experiments from the workflow. I can now search and find my experiments that maybe made a common precursor product and add it. I'm doing this twice. I've added precursor A and precursor B. There's some ability to filter on notebooks and projects to make that a little easier. And as I select those nodes, you can see all that information, the ingredient genealogy for each, the samples, and files associated with those. And this next step now, what I'm doing is creating a new experiment from those pre-existing experiments. And that's going to trigger, the standard flow of products from the upstream tier into the ingredients of that downstream tier, which is pre-existing capabilities that you're probably familiar with. If I click on those connectors, I can see which samples flowed in that upper table. And if I drill right into that, I can see that precursor A and precursor B have now become ingredients of that new child experiment. So we've extended, really made this much more flexible when designing these workflows by having that ability to include those precursor experiments in these workflows and then potentially in multiple workflows where you use that common formulated product. And in this last step, what you saw me just do, similar to creating a process experiment downstream, We also still continue to support creating those test experiments for characterizing the samples downstream. All right, so in summary, we've shown you some great new features in small molecule workflows, including Elemental, our chemistry toolkit, reaction workflows, and reaction explorer. Jumpa showed you expanded capabilities when you set up ontologies to manage your vocabulary and terms. We both showed you some of the new features in support of Prism and Prism 10. We've gone through some powerful additions to screening and screening analysis options, including the fitting model, the weighting model, and one-way ANOVA. We've shown you the instrument integration, the integration with Luma Lab Connect for management of instrument files and connecting them to experiments. And in this last section, we've run through a wealth of the new formulation ELN capabilities, really highlighting some of the major additions. We did present highlights today, not all of the new features, and you may have questions about these and other features that are available in the 7 series. We're happy to address a few of your questions in the chat now before the webinar ends. And we'll also try to respond to any offline we're unable to address now in the webinar. Additionally, you can also find more information on our website. Technical support is available either through the community porthole at community.dotmatics.com or by emailing support@dotmatics.com. And you can conveniently access that documentation again through our support portal at support.dotmatics.com, or if you're in the platform now, your current customer, in the top nav bar, you can click on the question mark to get access to the documentation and learn more about these and other features. So on behalf of my colleagues at Dotmatics, thank you for attending our webinar and have a nice day.